Hey, good morning. I got a lot of ground I want to cover, so I'm going to jump right in. As you heard, the theme of Rev this year is breakthrough innovation. We are going to hear from Jennifer Doudna, who won a Nobel Prize for her work to develop CRISPR gene editing. And we're going to hear from speakers at companies that are using data science to pioneer innovation in their industries, like Johnson & Johnson and Verizon and Allstate. This morning, I want to talk about unleashing data science innovation. And to get us started with that, I am going to talk about mold. This is penicillium, and it led to one of the most important breakthrough innovations of the 20th century, penicillin. Now, the popular story of penicillin, which I'm sure a lot of you know, is in 1928, Scottish scientist Alexander Fleming accidentally left a petri dish with some bacteria in it by a window before he went out of town. When he came back, he saw there was mold growing in the dish, and he was about to go throw it out, but he looked at it under a microscope, and lo and behold, the mold was breaking down the bacteria's walls, and it was killing the bacteria. Yada, yada, yada. Decades later, Fleming's got a Nobel Prize, and he's credited with saving hundreds of millions of lives. And this story reflects a popular view of innovation, namely that it happens when the lone genius has the flash of insight, like Newton conceiving of gravity when the apple falls on his head. But the reality of what it takes to turn insight into impact is much messier and more complicated. So let me share a slightly more complete version of the penicillin story. First of all, Fleming, this is Fleming, he didn't realize the medical implications of his discovery. In fact, he never tested his mold outside of a petri dish. It took an entire decade later for two Oxford scientists to see the potential of his work and to advance it for medical purposes. That was Howard Florey and Ernst Chain. And these guys spent 3 years experimenting with ways to concentrate and purify mold to make it suitable as medicine. And as an aside, the next time you hear a data scientist complain about cleaning data, you should remind them some scientists spend years of their lives working with mold juice. So anyway, by 1941, these guys were ready to test their medicine on human subjects. And they gave, one of their first subjects, they gave it to a policeman who had become desperately and pathetically ill. And it was miraculous. Almost in front of their very eyes, he began to recover. Until they ran out of penicillin, at which point his recovery reversed course and he quickly died. Now, World War II was going on by this point, and that was creating urgent demand for medicine like this. So Florey and Chain connected with the US Department of Agriculture lab in Illinois. And there they got access to military funding, to industrial-grade production equipment, and to a much bigger team. And they experimented with everything from different source strains for the mold they used to different ways of feeding it, and they figured out how to scale production. And by the time Allied troops landed at Normandy in June of 1944, they were carrying penicillin with them along with their weapons. So if anyone in the audience today has an ancestor who fought in World War II, there's a decent chance you might not be here without the work that these folks did. So what does all this have to do with data science? Realizing the potential of data science innovation requires turning insight into impact. And unfortunately, a lot of companies today, or I should say, the question we should all be asking ourselves as data science leaders is our work more like the mold in the petri dish, or is it more like saving lives on the battlefield? And unfortunately, a lot of companies today still seem to view data science as like the lone genius flash of insight. What I mean is they seem to think that you sort of sprinkle some AI pixie dust or some AutoML on your data and the insights pop out. But the companies that are winning with data science are doing the hard, disciplined work to operationalize it at scale. These are model-driven businesses. They go beyond being merely data-driven. They use data science to automate decision-making, automate business processes, automate product behaviors. They weave data science and models into the fabric of their business. And by doing so, they unlock new revenue streams, they create major new efficiencies, and they create superior customer experiences. They can do that because compared to human decision-making, models act much faster, they are less biased, and they learn and evolve, so they continuously compound incremental improvement. Models give companies superpowers to outcompete and out-innovate their rivals. And COVID was like a crucible that accelerated this trend. We saw companies not merely survive, but thrive by investing in data science in the face of uncertainty. By the end of last year, Johnson & Johnson was applying for more AI-related patents than any other pharma company. They built deep learning models to help diagnose prostate cancer. They built other models to manage their supply chains, which were critical as they scaled drug production. These models saved lives. John Deere released new sprayers that use computer vision to precisely identify and target weeds when they sprayed herbicides. These models help to feed the world and protect the planet. And Top Denmark, which is the second largest insurance company in Denmark, has automated core business processes. In a majority of cases now, their customers can get instant automatic decisions on policies and claims. These models are helping to create loyal customers and beat competitors. At Domino, we have never been more proud to be helping model-driven businesses unleash data science to address some of the world's biggest challenges. And we made a short video to show you a couple of these stories. Take a look.
The mission and the purpose of data science at J&J is one and the same with the overarching mission and credo of J&J, which is to improve the trajectory of human health. We use data science, everything from AI, machine learning, to real-world evidence, to digital health, to improve the medicines and therapies that we're making for patients. Imagine if you're a patient that unfortunately has been diagnosed with cancer. And now there are certain mutations where there's a treatment that can improve the outcome for you. But increasingly it's harder to find those patients because these mutations are new and therefore are not sequenced on a regular basis. But remember, every single patient gets a biopsy. So what we have done using data science is digitize those pathology, those biopsy slides, and then actually used AI machine learning to be able to predict what mutation a patient might have just from those images. You can find patients who may otherwise have been undiagnosed, or you can find them earlier.
Ford has a proud history and a great legacy, and really about putting the world on wheels and providing transportation and mobility. Machine learning is critical to many things that we do today. It's important in our products, some of the features, and just making our products smarter and more capable. It's also critical in many of the ways that we operate, in our manufacturing systems, in our engineering, and everything that we do. Of course, with our customers' consent, we're able to use crowdsourced information about how vehicles are operating, and then redistribute that information to the vehicles so they have a much more accurate estimation of their range, as one example.
New York Life is a very old and very large life insurance company in the United States. We're over 175 years old. We have a multitude of projects doing things like predicting mortality, doing things like predicting success of agents. We also have lots of marketing projects that predict things like retention and cross-sale and lifetime value. So all of those are deeply embedded in those business processes and creating value every day for the company.
The platform that we have, where we're building models and we partner with Domino on that, really has been one of the underpinnings of being able to scale. When I say go from 10 to 100, now actually probably 150 plus projects, you can't do that unless you have a standardized way of having all the data, models, applications in one place.
Domino powers data science at Ford Motor Company. The data science teams using Domino now have faster access to many of the tools they need. What data sets they're using helps avoid or eliminate redundant work, and in general, work faster. Domino has allowed our data scientists to collaborate much more efficiently.
Domino allows us to have all of our models on a single platform, and then have that platform communicate via an API to any production system in the company. So that's been a big game changer for us in the drive to deploy everything and deploy everything relatively fast.
These companies are doing the hard, disciplined work to operationalize data science at scale. They're not merely dabbling. And that brings me to the first big thing I want to make sure everyone takes away from my talk this morning. Playtime is over for data science. If you can't repeatedly turn data science into business impact, if you can't describe that impact, if your work is still relegated to an AI innovation lab, then you are already behind, whether you realize it or not. So what are these companies doing? What are the sort of secrets to model-driven businesses being successful? Well, the great thing about Rev is you're going to hear from a lot of them directly. And so a lot of them are speaking, grab them in the hallways, pick their brain. I want to share some of the recurring patterns that I've seen from working with the most effective, successful data science organizations over years. And there are 3 core ingredients, core building blocks that I have just seen over and over and over again. They empower expert data scientists to build an experiment. They make it easy to productionize data science work. And they forge deep cross-functional relationships with the business and with IT. Let me tell you a little more about each of these. First of all, they hire professional data scientists, the best ones they can find. And then they equip them with all the resources they need to experiment and build. That means the compute resources, the data, the software tools they need, whatever it is. The way they think about this is they try to minimize the time from when a data scientist has an idea for something they want to try and when they can actually try it. And look, I should say, there's a place for folks with less advanced skill sets, the sort of the analysts or the drag and drop folks. But no company is making deep, meaningful progress in this domain without a core of expert data scientists. Then they make it easy to get data science work productionized. And again, I should say, this doesn't necessarily mean that everything has to become a web-scale, real-time API. But my point is that simply prototyping an idea doesn't create impact. Companies have to find ways to get data science work integrated into the business processes and the systems that ultimately affect tangible decisions and outcomes. And finally, data science teams work hand in glove with the business and with IT. They align priorities, they share goals, they collaborate closely at all levels of the organization. And the partnership with IT is becoming especially important as advanced infrastructure and technology becomes more critical to enabling data science teams to build an experiment. And this is the second big thing I want to make sure everybody takes away from my talk this morning. These 3 core ingredients for data science innovation and impact: empowering experts to build, creating paths to production, and deep cross-functional collaboration, especially with IT. By the way, there are echoes of these themes in that penicillin story I shared, and I bet we're going to hear some more from Dr. Dowden this afternoon. Now, unfortunately, here's the wrinkle. The more success that a company has with data science, the more they can start to face back pressures that threaten or make it harder to sustain these core ingredients. Let me give you a couple examples of what I mean. First, the more that a company identifies more use cases and applications for data science, the more that can create challenges for data scientists to be adequately empowered with all the resources they need to meet the demands of the business. To give you an example, one of our customers had some early success with a deep learning natural language processing model, and the business wanted them to scale that same technique to sort of apply it in other places. But the data scientists quickly became hamstrung on limited access to GPUs, and so they couldn't meet the demands and expectations that the business was hoping for. In a similar vein, the more that data science touches more parts of a business, the more it can become challenging to get work productionized, because you're increasingly having to bump into more diverse and more idiosyncratic production systems. To give you another example, one of our customers had a model that was having success. They wanted to scale it or deploy it into international markets, but that work quickly got gummed up because they found out every different international market had its own separate tech stack and idiosyncratic data security requirements. And finally, as data science touches more mission-critical data and business processes, that can heighten tensions with IT. Because IT, understandably, cares about things like governance and security. And then data science comes along and they want more and more compute resources and they want more and more software tools. And then IT gets concerned about cost management and operational burden and complexity. And so data science and IT can have goals that become increasingly at odds. These dynamics create real challenges for companies as they scale data science. They make it harder to empower experts to build, they make it harder to productionize work, and they make it harder for IT and data science to collaborate. It's almost as though data science gets crushed under the weight of its early success. So what's the solution? What are companies supposed to do? Well, obviously, leadership and culture and organizational structures have a massive, massive role to play in unleashing data science innovation and impact. And you're going to hear a lot about that over the next 2 days, as we already heard some from Mike. At Domino, we think about the role that technology can play in unleashing data science innovation, and that's what I want to wrap up with this morning. When I look at the technology landscape today around data science, I see two very different approaches. And I think as an industry, we're at a bit of a crossroads. On the one hand, there are walled gardens. They promise the simplicity of a one-stop shop. And this can appeal to IT because less choice makes things easier to manage and easier to govern. And data scientists can build and productionize work as long as they kind of stay within the confines of the walled garden. But these walls create real limits and constraints. And data scientists are out of luck if they want to venture outside of the preferred set of algorithms or compute frameworks or infrastructure. And then there's the second approach, and this is the third thing I want to make sure everybody takes away from my talk this morning. We believe the future of data science is open and flexible. Because the ecosystem is evolving so quickly, and I think we're still in fairly early days of really refining and honing our techniques and our methods and our tools. So over the coming years, to beat rivals and to win the war for top talent, companies are going to have to be able to access the latest and greatest compute frameworks, software tools, packages, algorithms, data sets, data sources, you name it, whatever those resources might be. This is our vision for Domino. It's a platform that makes it easy for data scientists to build and productionize work with the flexibility and choice that they want, while giving IT the control and the security and the governance that they need. Rather than a walled garden, we picture a network of pathways integrated into the ecosystem and connected safely and securely. Now today, we've got about a dozen new capabilities to show you in the platform that further this vision. And to show you more and tell you some more, please welcome our Chief Data Scientist, Josh Poduska. Thanks, Josh.
Good morning. It's great to be with you today. At Domino, our North Star is to speed up the development and productionization of data science work. And we believe this is best accomplished by giving data scientists freedom while giving IT the security and control they need. Today, we're going to show several new features to unlock faster development and easier productionization. But before I get into that, I want to double-click on the ecosystem and on IT's needs. First, when it comes to the ecosystem, we have been investing in integrations with two key players in the data science landscape, NVIDIA and Snowflake. Now, obviously, data and compute are both critical to data science. And you can't talk about data without talking about Snowflake, and you can't talk about compute without talking about NVIDIA. So what you're going to see in a minute is how we are making it much easier to leverage NVIDIA and Snowflake across the data science lifecycle, from experimentation to production. Second, let's talk about IT. To build product that IT loves, you have to understand what IT cares about. Now, while data science cares about compute, data, and software, IT needs to reduce spend and operational complexity to ensure security and to increase consistency and standardization. I want you to keep these in mind as you watch the demos you're about to see. As we've been building new capabilities to unleash data science, we've kept these IT concerns front and center. The result is software that both IT and data science love. Okay, now for the fun part. First, we have a set of new capabilities that make it easier for data scientists to build and experiment by putting more compute, data, and software at their fingertips. Let's take a look.
I'm going to show you how Domino makes it easy for data scientists to experiment and build, while also keeping IT happy by reducing costs, securing data, and standardizing software tools. As an example, I'm a data scientist at a large health sciences company and need to develop a model for processing brain scans. I'll be working with hundreds of gigs of data and want to be able to train efficiently so I can try multiple experiments without having to wait days for the results. I want to use the latest open source packages for image processing, but I don't want to deal with installation, configuration, and GPU driver setup. Domino lets me create new compute environments with one click, meaning that I have the flexibility to work in a software environment that's already been properly set up and configured, saving tons of manual DevOps work. And we recently introduced a major enhancement to Domino compute environments. Data scientists can now create these environments directly from external pre-existing Docker images, without the need for any additional configuration. This is fantastic for data scientists, and also for IT, since it means they can now allow data scientists to use images from their internal secured image repositories to ensure proper compliance and validation is in place. We've also designed this to work seamlessly with NVIDIA NGC containers, a repository of GPU-optimized AI images. Let's say I want to use the latest TensorFlow image, with everything pre-configured to work with my NVIDIA GPUs. I can just input the URI to the relevant NGC container, and Domino is ready to go. This one-click access to pre-configured external images is going to save data scientists tons of time. Now, I'll move into my project, which is where I organize and track my work, experiment, and deploy models. Domino has always supported connections to diverse data locations, and has now made it even easier with the introduction of Domino data sources, which eliminate the need to install specific drivers or libraries. We have numerous built-in data sources. In this case, I'm going to select Snowflake and add details about the database. I'll then add credentials for my individual account, but my admin can also add service accounts and make those available to me as well. These credentials are kept in Domino's encrypted secret store, backed by HashiCorp Vault. Our newest release brings more advanced authentication to data sources. Domino can now use external identity systems, removing the need for long-lived credentials and adding another layer of security by centralizing access management. Now that I have my data set up and my environment created, I'm ready to begin training my model. I'll be using Domino's interactive durable workspaces, which give me flexible access to the hardware and tools that I need. In this case, I'm using the NGC container-based environment I created earlier and Jupyter Lab, though I could easily use any other IDE I prefer. A great new feature that Domino has recently introduced is intelligent volume provisioning, which will analyze my project and recommend the best volume size. This helps reduce cloud spend and operational burden. Next, I'll attach a distributed compute cluster. Domino already had Spark, Ray, and Dask on-demand clusters available, giving data scientists easy access to the power of distributed compute with the click of a button, without the need for IT to manage the cluster or pay for it to stay up when not in use. Today, we're announcing the addition of on-demand MPI clusters, giving data scientists the power to run multi-GPU, multi-node training with unrivaled efficiency and fine-grained control, providing even more flexibility for high-performance computing. I'm going to use a cluster of 16 GPU nodes, but can scale this up or down as I experiment. Domino addresses IT concerns around cost by giving admins the ability to set controls for hardware usage, including the choice of how many machines each data scientist can use concurrently, customized notifications about running time, and the automatic shutdown of machines. Now that I'm in my workspace, I'll start by accessing my data. Domino's Data Sources feature has an associated library that makes it easy to access both tabular and file-based data, and even provides a code snippet that I can copy and paste to get started. As I experiment, I can submit training jobs to the MPI cluster with minimal setup, since Domino has created all of the necessary environment variables I need to easily connect, and has copied my files over to each of the nodes. Without Domino, I would have had to manually deal with networking and MPI host files, copy data to the cluster nodes, and install necessary packages on the cluster machines. In this example, training that would have taken several hours on a single node is finished in minutes. Domino is the only platform that empowers data scientists like this by putting the software, data, and compute they want right at their fingertips in a familiar interface. If I pause my durable workspace, Domino preserves my work and spends down my compute resources to save costs. If I resume later, it will reinstate all my work with the click of a button. And my IT team is thrilled because Domino reduces operational burden and cloud spend while keeping everything secured and managed.
Thank you, Andrea. With easier access to compute data and software access that's also safe and secure, data scientists will unlock more breakthrough innovation. But all those breakthroughs will only be valuable if they can be operationalized, meaning if they can be integrated into production systems that drive action and decisions in the business. We're making this easier too, with new ways to productionize data science work. Let's see how in the second video.
I'm going to show you how Domino makes it faster and easier than ever before to turn data science innovation into business impact. As Nick said, we believe model-driven businesses will need to integrate models into a variety of different business processes. Our vision is for Domino to be a single pane of glass to productionize data science work. In fact, Domino already lets data scientists deploy work in a variety of ways. As APIs hosted in Domino or in AWS SageMaker, as interactive apps, or as batch scheduled jobs. Today, we're introducing 3 new ways to deploy data science work to address emerging use cases. Hosting deep learning models with GPU-backed APIs, deploying models to the edge with NVIDIA Fleet Command, and in-database batch scoring using Snowflake. Let's look at each of these in turn. First, we're adding support for GPUs in our model inference REST APIs. This is important as more companies are beginning to operationalize models that use unstructured data like text and images and benefit from the performance of GPUs. Domino enables data scientists to deploy models with GPUs in just a few clicks. Let's say I want to publish a model I built with TensorFlow using a compatible Docker image and extended with external repos like ngC. I know my inference is going to be compute intensive, so I need to deploy the model with GPUs instead of CPUs. In just a few simple clicks, I can select the GPU configuration suited for my model, and to scale my endpoint, I can deploy multiple instances, each with their own powerful GPU. That's it. Now it's easier than ever for data scientists to deploy models for NLP or image processing use cases with the inference power of GPUs at their fingertips. Next, let's look at another increasingly important way to productionize data science work, scaling AI applications at the edge. This is becoming critical for use cases such as anomaly detection at cell phone towers and quality control in manufacturing. Domino's new integration with NVIDIA Fleet Command makes it easy to deploy models to the edge. In this example, I've built a model in Domino to evaluate the remaining useful life for a turbine valve and want to deploy it to an edge application. With a simple API invocation, Domino packages the image and associated artifacts and registers this containerized model with Fleet Command. Note that I can also use this API in my CI/CD workflows to automate model deployment to the edge. Now, I can visit the Fleet Command console to configure the Edge AI application to invoke my turbine valve health model. With Domino's model export catalog, I now get a unified view of all exported models and their performance, so I can track and manage my production assets from a single pane of glass. By simplifying this process down to a few steps, Domino has made it really simple for data scientists and their IT counterparts to operationalize a model at the edge. Finally, let's look at in-database scoring in Snowflake with integrated model monitoring. Snowflake is now the canonical data store for many companies. Moving large volumes of data to the model for inference can be costly and involve security concerns. Companies are now shifting to an approach where the model comes to the data. Today, we're announcing Domino's integration with Snowflake Snowpark that makes it easy to deploy models for in-database scoring at scale. Let's see how this works. In this example, I've built a customer churn prediction model in Domino, and I've written my inference function that I intend to invoke from Snowflake. With just a few simple steps, Domino lets me select the function, specify the necessary connection details, and takes care of registering my model and code with Snowflake. I can now hop over to the Snowflake console and with a simple query, execute in-database scoring, invoking the churn prediction model I just exported. It's that easy. Fast forward, the deployed model in Snowflake has been used for making batch predictions, and I've received a data drift notification. In this case, I can see that the two features that have drifted have untrained classes, and this gives me enough information to remediate the drift. Domino has made it easy to productionize my data science work across a variety of destinations and use cases, and all within a single pane of glass that offers simplicity for data scientists and governance for IT.
Thank you, Vinay. Domino gives data scientists unprecedented flexibility to experiment and productionize their work while giving IT the security and control they need. We can't wait to see what new innovations this unlocks in the next generation of model-driven businesses. Nick, back to you.
All right, we have one more announcement today, and I'm so excited about this. It's going to be a game changer. I cannot wait to tell you all and show you all about it. To set the stage, I want to highlight some of the tensions that we hear when we talk to our customers. On the one hand, everybody wants more compute for more data science workloads. This is being driven by increasing demand and success for deep learning use cases and unstructured data, by growing data volumes just in general, and by more computationally intensive algorithms. But on the other hand, compute is really expensive, especially those sweet GPUs. On the one hand, everybody wants to apply data science to more critical, core, and secure data sets. But on the other hand, the more secure a data set is, the more it's harder to access, the more it comes with restrictions. We talked earlier about how, in some cases, data can't leave a certain region because of data locality restrictions. And finally, there's cloud. On the one hand, everybody's moving to the cloud, or everybody's in the cloud already. But on the other hand, being in the cloud isn't really a binary state. It's more of a spectrum. Even companies that are already in the cloud have data that's still on-premise and will be for some time. And eventually, everybody wants to be in multiple clouds anyway. When we talk to data science leaders and IT leaders about what they really want, what we hear is basically some version of, I want the best of both worlds. Meaning they want to be able to run some compute, or a lot of compute in the cloud, but they want to have the flexibility to run workloads on-premise when it's more cost-effective or more convenient, like GPU clusters. Or they want the security of segmented data infrastructure, but with the convenience of a single way to access the data and without the complexity of different tech stacks. Or they want to be able to move to the cloud, but they want to be able to do it incrementally and without the risk of lock-in. Today, we're announcing a new hybrid architecture to address these challenges. It is going to be a single control point that will let companies run data science workloads across different compute clusters, whether those are in different regions or on-premise or even across different clouds. We're really excited about this because it's going to unlock more experimentation and make it easier for data scientists to build and productionize work while giving IT the help they need to control costs and security and governance. It is going to be a major step change for data science infrastructure. Let's take a look.
Thanks, Nick. We set out to create an intuitive, seamless, and almost a magical experience for data scientists that puts infrastructure at their fingertips from one central interface. It's quite an engineering challenge to build something simple and intuitive that's also enterprise grade for the hybrid world. Our engineering team is solving for some unique challenges that come along with building a hybrid cloud architecture. Our architecture today is built to handle unpredictable nature of hybrid cloud connectivity, which can be intermittent and high latency. With the help of message brokers and custom Kubernetes operators, we can now help data scientists focus on their data science work during these interruptions. We're building our architecture by keeping the stringent security needs of enterprise IT in mind, by supporting encryption at rest, secure TLS connections, and outbound-only connections from our customers' infrastructure. While at the same time, we want to hide all of this complexity from the data scientists and build a user experience that's simple and familiar to our Domino customers. We are so proud of the work we've done so far and really thrilled about the delightful experience we're building for you all. Now let's walk through a real-world example so you can see what it looks and feels like. Imagine I'm working at a multinational bank with infrastructure that's spanning across multiple regions, multiple public clouds, and on-premise resources. Some of my data is locked into certain regions because of the GDPR requirements. Let's say I'm building fraud models that use images representing document scans. I want to begin by quickly prototyping a model by working on a small sample dataset. So I decide to launch a workspace, and I notice a few different options for hardware tiers that are backed by different infrastructure providers. First thing to note is that my IT organization is going to love this because I have an abstraction layer in front of different cloud platforms, reducing my lock-in risks and making it easier to implement a multi-cloud strategy going forward. All right, so I want to choose the one that's smallest and that can be quickly spun up. So let's go with CPU small in AWS. As you can see, Domino is spinning up a new workspace for me in AWS, and I continue to prototype my model there. Fast forward, I'm quite happy with where I am with the prototype, and now want to train the model on a full-size dataset that's approximately 200 terabyte. I decide to launch a Domino job to train the model. As the dataset is huge, I know I'm going to need GPUs to ensure good performance. Looking at the options, I think I'm going to choose my on-prem NVIDIA GPU cluster. I am happy because I have one-click access to powerful GPUs, which are normally complex to access, and my IT team is happy because for a training job of this size, I would be paying a fortune looking at the AWS GPU prices, and is zero marginal cost for my on-prem cluster. Just to recap, so far I've done prototyping in AWS and my training on an on-premise NVIDIA GPU cluster. And I'm happy with my results, but there's actually one more wrinkle I have to deal with. Earlier, I said that the 200 terabyte dataset was the full dataset. Well, that wasn't quite true. See, I need different versions of this model in different countries because of the differences in document format and languages in different regions. Several of those regions have strict data privacy regulations that restrict data from leaving the region at all. So to train some country-specific models, I actually need to use country-specific data. Now imagine doing this without Domino. You would have to locate the data, find out the cloud provider that's available in that region, file a ticket with IT to get access to some infrastructure that's appropriate, then upload that data. All of this before you even get to training the model. Now imagine doing this multiple times for other countries and the amount of precious time you would waste. With Domino, I can do this in minutes. I can trigger multiple jobs by choosing different compute options that IT has already provisioned for me. And notice that based on the infrastructure that I chose earlier, Domino automatically identified the right datasets that are accessible from that region. That is neat and is going to save me a ton of time. By the way, as a data science leader, I can track all of these jobs running across different regions under a single Domino interface, making Domino my single system of record for all of the data science work, no matter where it happens. Now that I've trained my models, I want to deploy them in different EU regions. Vinay already walked you all through the deployment workflow. And with Domino Nexus, now I can choose different compute environments and deploy my models across different regions, clouds, and on-premise clusters. Now think about the end-to-end workflow. This would have been practically impossible without Domino, or it would have taken weeks worth of work to move the data around and manage different environments. Domino made it seamless and simple, all while massively reducing our cloud compute bill, keeping our data secure, and enabling IT to incrementally pursue a cloud migration strategy. Back to you, Nick.
What'd you all think? Yeah, it's pretty cool, right? Okay, we're going to be shipping Nexus later this year. We're starting our preview program. If you want to be a part of this, we'd really love your feedback. You can shoot us an email at nexus@dominodatalab.com or come see us at our booth after the talks here. And with that, I'll just say thank you and enjoy the next 2 days at Rev.